Welcome to this week's CLM for the summer. A couple housekeeping issues. We'll be meeting through June and July, Wednesdays, 1 p.m. to 2 p.m. We'll try and get notifications out for the video conference. But today I'm presenting and going back to the radicalization model. This is something that I started in the quals, and then I presented at the colloquium, and I am now beginning the progress of taking all that work and sort of focusing it, narrowing it, simplifying it, and getting to one really good concrete article out of it, which I can hopefully apply to my dissertation. But today, what I'm looking for is, I'm going to present just kind of some points of what I took out of the colloquium. Is this sufficient for an article to focus? I want to review the behavior modes and behavior mode slices I have, and then also I'm converting, which Professor Said would be really happy to, I'm converting the Vincent model to Stella. And so as I build the model, I'm looking for what are good practices to take advantage of Stella architecture.
Sorry.
Yeah.
A side note. Will project dynamics be offered next semester? Because I talked to Kareem and he didn't know about this.
I'll check.
Oh, the spring. The spring.
Yeah, please.
Okay, because when I talked to Kareem on Saturday or Sunday, he was like, "What are you talking about?" And Stella maybe.
Yeah. I may be emailing him or his folks for help at some point, but I got fairly far along. So just a quick summary. This should be review. I think everyone's seen this, so we won't go over. But it started with a debate between Sageman and Hoffman on two types of radicalization: a swarm process versus a fisherman process. I created a causal loop diagram that combined both authors' visions. So this is representative of the authors' theories. To say, look, we can make one causal loop diagram. I then made a model, and the model showed system state behavior. So
Just a second, can you go back to
Sure.
the previous diagram? Are these two, in your model, these two causal diagrams are linked?
yes, if you look actually down here, you can see that narrowcasting and broadcasting are inputs to the radical interactions as our experienced fighters. But what I'm hoping is to get a more generic causal loop diagram that's a little cleaner using the modules of Stella.
And what are the outputs of these escalation processes?
Yeah, so this right here of rated mobilization feeds back into domestic radicalization. So this is a successful loop of radicalization and de-radicalization, and the gain of this loop, it's a positive gain, you're going to have more people radicalized. If it's a negative gain, you're going to de-radicalize or prevent people from being radicalized. So it's a gain there in the system.
So this is a combination of both of the authors?
Right. This is both authors' theories presented into one causal loop diagram. It's got a lot of stuff going on there because I was trying to be accurate to them, but I think in this article I can try and simplify it a little bit and say this is exploratory and notional. And my goal here is to get a generic structure for radicalization. They were talking about Salifi Takfiri. That's what I have the data on, but I'd really like to pivot in this article to say this is a general structure that can help us when looking at white supremacists, left-wing terrorism, right-wing terrorism, environmental terrorism, all the different incel, all these different concepts of radicalization, a more generic structure, I hope would come out of this, while also resolving their debate. These were the rather ugly diagrams. I hope to not show too many more times because I'll have much better, prettier diagrams in Stella. But it's a system state map. So if you think about it in quadrants, the upper right quadrant means the system is operating in a swarm. The lower left means it's operating in a fisherman. And the two are sort of hybrids. And it just shows, and there were 50 runs done, and these were just the selections that even though the system starts in swarm, because the way I initialized it, it moves back and forth. So in this case, it moved down, touched into fisherman, went back up into swarm. Here it went down and stayed into fisherman. Here it had this very interesting path. And it's looking at what are the contributors of radicalization? Where are the sources coming from? But the feedback I got from this was that a good article would be to explore these system states and understand the contingencies under which the different kinds of system states arise, and actually spend some time to sort of name what these quadrants are and have clearer pictures to say, okay, here's a swarm, here's a fisherman, here's a fisher swarm, or something like that. Describe what those are and how policy choices lead to different transitions through these states. this is review from the colloquium. We kind of showed that it.
I guess just a suggestion. Instead of fisherman's swarm, maybe descriptive names like susceptible to external influence and endogenous. Endogenous, actually, basically, there is endogenous and exogenous influences. And then the other two quadrants you might think about in these terms, like these two guys, one is focusing on endogenous causes, the other on,
One of the questions I had, because this came up, is in making it generic, in the original models, the concept of foreign terrorist organization and a safe haven overseas and all these kind of other, but I'm wondering in a generic model, could you have a domestic terror organization? And it has a safe haven that's operating from within the country that is sort of an area that might not be as able to exert. Could that still be exogenous and endogenous in the terms of maybe endogenous is from the person and exogenous is from an organization wherever it exists? Would that still fit?
So it's more like gangs.
It could be gangs. It could be like the Bundy Ranch situation in Nevada, where you had an area, a part of Nevada that's fairly conservative, had an anti-government movement, has strong anti-government presences. They're not necessarily in open conflict like you might see in a foreign war, but they certainly gathered together a lot of individuals very quickly. I'm not sure if gangs is correct, only because radicalization is I think a different psychological process than gang joining. And so like radicalization in the literature is not just the willingness to fight someone else, which like a gang or an insurgent might do, but the willingness to harm someone who has no obvious threat to you and to harm yourself in pursuit of like to commit suicide or things like that, or to risk things.
So I think the difference seems to be that in that upper feedback loop, which is the
this one here is the terrorist organization influence.
There's the swarm.
Yes, this is the swarm influence. This is fishermen. Excuse me.
This is fishermen.
Yeah, these are fishermen.
So that actually portrays the process as endogenous, right?
Right.
And the lower escalations just speed it up, basically. So they go back to sort of escalate what's happening.
Right. So
endogenous.
What Professor Said is talking is this is the kind of the core loop of radicalization, and these ones are simply accelerating it or slowing it down.
Yeah. So basically accelerating it because there are positive feedbacks. Unless the gain is negative, they'll be accelerating that process. Now, that model is a model of an endogenous process.
Right.
And those are the external causes that you're adding. So basically, I think your model portrays the endogenous causes in some detail.
Yeah, I think the only exogenous things, and I'll show you when we get to Stella, because it's in there, is the policy choices that are put into the system. Because I wanted to portray the dynamics of radicalization in an endogenous system.
Policy choices are based on perceptions.
Right.
If the perception is that the process is endogenous, then there are different policy choices. If the perception is that it's exogenous.
So let me explore this some more, some endogenous and exogenous characterizations.
So I'm saying this because if you're building on those two opposing theories, then they focus on endogenous and exogenous processes. Right. And maybe it's not a good idea to aggregate the two.
Would it be worth, though, if I'm attempting to resolve the thing and say these behaviors that they're each describing as sort of separate exist within the same system?
Actually, that's what you've described.
Right.
exogenous system reinforces the growth process.
Right.
If you like to do that, yes.
Okay.
So
Because I think that one of the outcomes is currently they see these as two incompatible theories as opposed to two contingencies of a system. Like they're describing, the way the system
and
operates.
your thesis will be that these are two contingencies of the same system.
Exactly. And here are many other contingencies of the system and or behavior states and what gives rise to them. That's the intended thesis. Is that a good thesis?
Yeah, I think that's the good one. Right? That's the good one. That, these are not two separate theories. These are manifestations of the same system.
So anyways, these system states will be replaced in the new model.
Maybe you can show the 4 quadrants and
Yeah, I'm hoping with Stella it's a little more.
spend some effort on. So
These are Benson. These are.
If we find them, what does the quadrant mean?
That's kind of what I'm hoping to do. I'm to make it graphically more appealing, and also if you remember from my ISIS work where I talked about, I had the 4 quadrant that I described as terrorists, insurgents, global insurgents, and emerging state actors, and sort of locate.
Yes.
Yeah.
And then a policy can move the system from one quadrant to the other.
Yes.
That's what needs to be explored.
Side note, you're converting all this to Stella.
Yes.
I want to learn Stella. Can I help you with that?
Possibly. I'm already like 3/4 done, but I'm happy to have some help on this the goal is, part of this is to simplify the model I had in Benson into Stella, but then to make use of Stella's functionality to be a better presentation and use the.
May I be a research assistant with you and help you with this? Because I also want to learn Stella and relearn SD 550 using Stella, redoing the models in Stella. That's how I wanted to learn Stella.
Mm-hmm.
Because it was invented.
I'm not sure how much Stella work there'll be. I mean, I'm happy for the help, but I think with Stella, the modeling itself is going to be fairly quick to complete, but then the work, which you may help on, is doing tests using Stella, the analysis of the model using
and you
tools.
might want to consider module structure.
You'll see that I've already started that. That's actually where I'm trying to get to the model. So this is all the past stuff, and I'm hoping to get away that we never see these charts again, but I'm trying to bring up to date sort of where we're at.
Can you just briefly say that argument of each of the authors?
Sure. So the argument of each of the authors, really simply, is that both of them say the same thing, that the process of radicalization is similar. And Hoffman says that foreign terrorist organizations are the one that drive this process. That because they are sending out media information, they're sending out recruiters, that they exist and are funding and have a safe haven, they're the ones driving this radicalization process. Sageman is over here on the right saying that societal and demographic pressures lead to self-radicalization, so that radicalization is not, you could have no foreign terrorist organizations and people would still radicalize. And they were arguing specifically over Al-Qaeda radicalization in Europe and the US over a period of time. And the data I had showed that they were both kind of right and kind of wrong. US was self-radicalized, Europe was largely affiliated. So in some ways, the data shows that they both had elements of truth in them, but they were so busy arguing with each other that they didn't break the data down that way. And the policy ramifications are, Hoffman says, if it's a foreign terrorist organization that drives this, then you want to intervene, you want to go after the safe havens, you want to use intelligence operations to disrupt them. Sageman's approach is, no, you need to do societal changes internal to the homeland, and that will change the radicalization, so you don't have to worry. It was not designed, and I think this came up before because you asked, they were not looking at a conflict zone itself, like in Afghanistan or Syria where there's a persistent state of conflict. They were looking at radicalization in areas that were not in current conflict. So like within the US, Europe, or an area that doesn't, because when there's an ongoing conflict, I think that's a whole different discussion that goes on with radicalization, which neither of them attempted to address. So this is more about how do you stop terrorism in the US and Europe was their main focus. I think there's applicability though for like this incel attack in Toronto. I think I can see parallels of the radicalization there within this small community. So I think there's a lot of application beyond just Salif Takfiri sort of Islamic terrorism type of questions into more general extremism. So this is kind of what the plan is, and some of this, but you know, the colloquium was to get the behavior modes in the author's hypothesis, but propose a generic CLD and exploratory model, catalog the system states that the generic model create, identify the contingencies in which they can arise, draw conclusions, and then profit. Ultimately, I want this to be an article I can submit and get published somewhere. What I need to do is convert the model from Benson to Stella and simplify it, narrow down the data set and slice it into behavior modes, create the system states, draft the article, and I did get this accepted for a poster submission. So I'll be presenting this as a poster at the conference. So in August, by late July, I've got to have a poster printed on this. So that's kind of keeping my rhythm going. These are the behavior modes. This is the first time these have been seen. These are the actual behavior modes taken from a terrorism database hosted by the University of Michigan. It shows in Western Europe, in blue were the affiliated attacks, the ones that had linkages to foreign terrorist organizations, and the red were the unaffiliated. And this was over 1995 to 2016. And so you can see it's obviously, it's tricky because it's a low incident rate, so there's periods of time with no incidents, but you have these kind of somewhat oscillating behavior, and then near the end, corresponding with the rise of ISIS, you have this very large increase. They were writing in this time period, so their entire debate sprung from this increase, you know, and this was causing a lot of concerns here. You'll see it in the US as well. And so obviously there's going to be a lot more increase because the last couple of years was greatly. This is the same chart for the US, far fewer incidents, so it's kind of even more choppy. But again, it's showing, you know, a dramatic increase in the last couple of years. When we slice this, if you've ever read Professor Said's Slicing Complex Behavior, what you can do is sort of try not to replicate the exact behavior, but look for behavior modes. And I found three sort of obvious ones. One was an oscillation around a mean. So there was a behavior mode where there was kind of, it seemed to be this oscillating pattern. There was an exponential, so this, you can see here on this one, here's the oscillating pattern, it seems to be. But you can also see there's this exponential growth. So I have an exponential growth. And then it appears to be that there's some sort of inflection point followed by a decline. And is this an exponential decline or a geometric decline? I always forget.
It's in the beginning, it's geometric and then comes exponential.
Okay, so it's you see these collapses. So these are the three behavior modes that I'm trying to get the model to replicate as slices.
I'm not very clear about the third one. What is it?
The third one, it would be, let's see. It means that after,
isn't this part of oscillation?
Well, it's when I talk about an inflection point here, for example, if Al-Qaeda, the hypothesis, Al-Qaeda was sponsoring a lot of terrorism up to and after 9/11, but then we intervened in Afghanistan, and there was a period of time where that behavior dropped, right? It's now got almost like a reinforcing loop, dropping it, not just a steady oscillation, but dropping it down dramatically. Likewise, the question would be after ISIS had its regional territory curtailed, does the terrorist incidence of ISIS drop dramatically as well? The problem is the data set that I'm working from is lagged. It doesn't. The latest it has is 2016, so it doesn't have anything from 2017 to 2018.
My question was, isn't it a part of the oscillation? The drop is a part of oscillation. Right.
In the current data, it is. The question is, I would assume that there would have to be a point where it drops and doesn't come back. Because if it comes back, that's the oscillation, right?
But that would be, that's not in your reference mode, that's not the data. That's a hypothesis. Is that a hope scenario?
That may be a hope scenario, actually. You're right.
Yeah.
Because it's not, you can't see it in the data here, because this one drops down and comes back. That's an oscillation. But I guess the hope is to drop it and keep it low.
So as far as the
Probably needs to be relabeled hope.
the initial model is concerned, you're dealing with two slices.
Right. The growth.
The growth and the oscillation.
Okay.
And that hope scenario is, that's the hope scenario.
Right. The inflection point being when you implement the policies.
Achieve it through policies.
Why are you doing these slices? You're picking slices of from the behavior mode.
Mm-hmm. So the there's an article Professor Sater wrote called "Slicing Complex Problems," and it recommends looking at when you have a complex behavior mode, rather than trying to look at that behavior mode, you look at elements of it, and you can look at time-based behaviors, population-based behaviors, or the specific behavior modes. Like, is it oscillating? Is it increasing? I just did the latter, which was, and from these we can begin to distill what is the structure that generates this. Systems theory teaches us that an oscillating behavior mode is at least a second-order negative feedback loop with a delay. You need that to create an oscillation. An exponential increase mode means there's a positive feedback loop out there somewhere that's operating. An exploding oscillation is a third-order feedback loop. I mean, you can begin to use systems theory to reverse engineer from a behavior mode into the structure of your model, what is necessary to recreate this. Plus, it simplifies what you're, for an exploratory model, what you're asking it to do. In the ISIS model, I was trying to recreate history. So it was a very complex behavior mode, and it required a lot of features and functions. I'm more interested now in the general theories of what causes this as opposed to recreating any specific history. So if my model can create an oscillation, it can create an increase, and it can create, for the hope policy, a decline, and those are at least plausible conditions, I've got a sufficient model for exploration purposes. Check me if I've got it wrong.
So basically,
You're the
there's a theory which underlies oscillation, and there's a theory that underlies exponential growth. And if you put them together, it's very difficult to conceive that complex theory. But looking at these two slices, you can conceptualize each separately, and if there's a need, combine the two.
So one thing I haven't gotten to yet, because I think I can do it within one model, but we did propose for another piece of work, is sometimes when looking at complex problems that might be a really big model, you build a small model that only seeks to replicate one goal. For example, if you think about this as steady state behavior, the oscillation is the steady state behavior. So what is a model that can create steady state oscillatory behavior?
Model is a theory.
Yeah, model is a theory. So what is a theory? But separately, what is a theory that could explain really rapid exponential growth, which you can see here, rather than trying to create one theory or model that encompasses both? So it's a way of sort of breaking down the problem a little bit into pieces. So I'm going to rename this the hope. You're right. This is really a hope, and then the feared, I could actually put the feared and
that exponential growth is fear.
Yeah, well, actually, yeah, because there's, and it, part of this is I want to use the standard method. It's sort of like I already know the answer in some ways because I've already done some of this. It's like the fear could be a better before worse behavior, that it looks like it's going well and then it goes really badly, which we saw in the ISIS case. But
so you're saying in the hope scenario that the oscillations stop and the growth stops.
yes,
So
which would be an interesting challenge.
yeah, that address is addressed by your policy experimentation, but the initial model may not subsume that.
Yeah. In the 50 tests that I did, one case showed this behavior.
I see.
But I need to sort out, I would never say that my quals model may have had some, errors in it, but I want to make really sure that the model is valid, not generating a behavior.
a week. So
It's already signed, so. So
over and behind.
let's jump over to the models. So this is Stella, and what I'm using is modules, and just to get a flavor, what I'm converting it from is this. So this is what the Vensim model exists as, and you can see it's a really complex eyesore. There's lots of things going on in it, and I'm trying to simultaneously convert it to Stella and simplify it by reducing unnecessary or redundant structure, using loop theory to say, do I really need to have this much disaggregation?
Like those 4 feedback loops, which were the fisherman
Yeah.
theory, could be merged into one.
Yeah, well, and they actually are now. So I've converted them into. So these are modules. So in Stella, which I'm learning, run along with me, Christine. These are now a causal loop structure that emerges from the structure of the system. So underneath these, you actually have. Let me decrease this. That's pretty high stuff.
If you click on that arrow up there, it will go back to the.
And I just need to shrink it so it's a visible size. There we go. Ooh.
What was the reason that you didn't do this in Vensim? Like,
I already had
So
original.
there's
The original model was in Vensim. I programmed much faster than Vensim. I did all this in about 2 weeks.
a simplified version that you're creating.
Yeah, one is I want to make sure I'm conversant in both models, so I don't just get like if I only use one, I'll only be good in that, and I need to challenge myself to stay fluent in both. Stella has a much more intuitive storytelling capability and a much stronger visual presentation capability than Vensim.
Also the hierarchical structure.
Yeah, that was the other one.
And if you press on that arrow up there,
I'm trying to get there.
to the right.
Yeah, the mouse is not moving.
I see.
Let's see if this.
So the feedback map sits on top of stock and flow structure.
Does anyone know what the key is for that? Because what's happening is my
You can at the same time on the same screen you can have both a causal loop and also a stock.
Yes, the causal
You
loop.
can also try to give them control of yours.
well, what it is this bar is hiding.
Oh, I see.
Yeah.
Uh,
Yeah, you should be able to disable that somehow.
Yeah, that's the. But if there's a keyboard command that actually goes up to the module structure,
Maybe more.
nah.
if you just push against the bar,
Just say
one
one.
shoot,
If I hide video panel, that moves that, but not this.
or if you reduce the size.
Of the overall size. Besides with that. Oh, I understand.
Oh, I see. I see.
So
Is that
if you
voice? Is that voice?
press on this
Wait, is there a
arrow,
voice? Is there a voice?
That's weird. I'm not on the audio.
Someone's on. Do you have?
I didn't.
Where?
so if you press on this arrow, and this, and we reduce the size of this.
There we go.
So that's the overall, that's the aggregate feedback structure. And if you double click on any one of the models, if you double click on any one, this is what's underneath that aggregate module. So this is the relationship, feedback relationship between sub-models which reside in the modules.
I'm gonna leave the meeting and rejoin it.
And actually, I just reduce those just to names so that it appears that if you double click on this, you double click on and outside. Yeah. And go down to this. There are these icons at the bottom. Yeah, for the right, the paint bar. And she
scroll down.
converter and further down. module then only. So here is,
This is what I want to
here's
learn
your
about.
mental model,
Exactly.
and you click on any name, and you have the feedback structure. There we go.
Great. That's
And even in this feedback start and flow structure, you can double click on this space, and again go to the game bar and go to the converter size.
mhm.
Click name only on converter size. So,
So this gives it the Benson
it's the Benson loop.
somewhere.
But
Kareem's
the module map really looks like a feedback map.
Yeah.
It's very nice relationship between mental model and the computer model. The mental model sits on top of the computer model.
And this is one of the reasons why I wanted to switch to just to use this module function. Plus, it's going to be a simple model, and hopefully in the process, it can also force me to challenge the assumption.
I logged out of it as well as something else.
I'm going to log out.
I was just testing whose it is.
Testing. Okay, so it's clearly.
And I don't think anyone's going to join, so I don't have to monitor the chat. It's already booked for half the time.
Yeah, it's summertime.
Yeah.
Well, we've had Saeed on the last couple ones.
But usually he's on time.
Yeah, he's out today.
Let me just.
So may I talk to you after this meeting about being a research assistant and just relearning, but also helping Tim and maybe what you think about it, because I think it's
Sure.
exactly what's
Yes, absolutely. Help 10. I don't have money though. Excellent.
But we can have that I don't want money.
Excellent. So you guys are hired as research.
Yeah, I'm really cheap. That's what people told me at the VA.
Testing.
I'm really cheap. It's true, I'm actually really cheap. I don't need that much money to survive.
Okay, so double check. All right, we're back. And all right, so this is the mental model now without module boxes, and you can see here that it has. Actually, I got to share the desktop so I can move back and forth. Okay, so if we go between this and the causal loop diagram, the causal loop diagram here has, we zoom in, right? It has things like, this is all rate of mobilization via network effects. It has pool of self-similar, it's got these loops. I tried to replicate those here. You have rate of mobilization, the population, potential and actual radicals, perception about terrorism, and how this kind of works now is you have a population of potential and actual radicals. They commit terrorist attacks. That fuels a societal response, which may exacerbate the problem, or it may go up and decrease or increase mobilization and creates a feedback that way. But there also, you can you're targeting with your societal response network effects, and then the safe haven and conflict zones. And this is the question of endogenous. Are we talking endogenous to a country, endogenous to a person, or endogenous to a system of radicalization? And that's, I think I need to really think about that.
I think it just a different set of interpretations of the same structure.
Yeah, it's all the same structures.
What I would suggest is, now that you have the overall simplified feedback structure, this is your dynamic hypothesis. Within each module, you can try to simplify the structure.
So one thing that I've, like, for example, and I want to make sure I'm doing this right, the network effects originally looked like right? This network effects were up here in this area. It had two stocks, it had a renewal rate, a regeneration rate, it had ways of reducing both. So this entire area here has been reduced to a single stock and flow.
Yes.
Is that what you're talking
Yes,
about? Okay.
absolutely.
With just a blended delay time to renew the networks based on the size. And then, questions, and this is more practices for people who are more experienced in Stella. This isn't much structure to look at, and that's good, but to go and find the next thing this goes to, you've got to go up here and say, okay, the network effects goes to rate of mobilization. Click here and see this is where it comes in, right? This is where here we go. This is the network effects. You see it comes in here.
This is also, I'm happy to see, reduced to just one stock.
Yeah, it's these input stocks are coming from the other modules. Yeah, and the safe haven one is right now, that's just one stock. I haven't expanded it, but I'm trying to get these two very simple. I think the only one which has multiple stocks is we have the population stock, which has people who aren't radicalized yet but could be.
But these are only, it's an aging chain.
Exactly, it's a simple aging chain. And then the other one is, and I did simplify this one a little bit too, this perception about terrorism, but this has multiple stocks in it, is it has a casualty, like it tracks casualties, which really could just, since this, if no one cared about the cumulative casualties over time, I could just convert this to an auxiliary. Because right now this fuels nothing in the model, but these two stocks are now an anchor expectation formation, a double, but that seems to be the appropriate structure.
Mm-hmm. That's
okay.
fine. That looks fine to me.
Yeah. So it's not
no component is overwhelming.
Okay.
And the overall picture is very understandable.
So even though there's lots of, is there a quick way to go to sectors without going back up to the top level?
Unfortunately not.
Okay. So then my next question, and this is more art and aesthetics than technical. Are these too many or too few? Because I originally, I broke this down into one feedback loop, which originally was, you can see here is the bottom half of this screen. This entire feedback loop is now broken into 3 modules to make it less eye strain, but it's going to require you to trace the loops and to trace the feedback to go clicking through up and down, up and down. And I'm wondering if there's any practices on the aesthetics of that. I can track it by saying, okay, where does this go? I can see here now. It goes down here. Great. Where does this go? I look at this and say, and now comes the societal response. I see the societal response. Where does that go? It now goes back up, and I've completed that loop. So but it feels like it's click heavy, but might also be much less eye strain to understand each component. So what are your thoughts?
There's a way to trace the feedback loops, and I think Rafat is more conversant with that than I am. Can help you with that. But I think I do see what you're saying about the clicks.
Yeah.
I don't like.
Now I think I can create in storyteller mode. I can create an interface layer that sort of guides you along the path.
That's what I do.
Okay. The interface mode of Stella, another reason.
So if you click on that TV screen up there, you will
crash the system. Yeah, there's nothing in interface yet.
So you can create a storytelling interface. You can create a experiment.
Do you think that a workable model that's going to be published in an article would benefit from spending time on the interface so that people can conduct their own experiments or work through the model in an easy way?
What I've learned is that I create an interface to conduct my own experiments. And it makes me make some nice runs, which I can copy and paste into the article. So it's if it can help others to experiment with your model, but at the outset, it helps you
Right. So it's kind of like a version of, in my original model, I do this a lot in Benson, is I have the messy structure, but this is where I have, these are all the choices you have on policies, and I can quickly set up a sim, adjust these, and then these are the graphs I'd be pulling from. So it's a version of that, basically.
So if you go to the Stella interface now, you can specify output. You can first of all specify the size of this panel. You have to do that. If you double click on the whites, so you can on the right side, where it's covered by, you are able to specify the size of this panel, and then you can create some output panels there. Yeah, you can. Usually comparative graphs.
Yeah, I've done some of this before. So if we have,
and then you can create sliders, and these sliders can represent any policy interventions. One before. So yeah, that's the slider. So to be able to specify this slider, you have to be in the edit mode, which you are.
Perception.
And you can, from these modules, you can pick any parameters. Yeah.
Right. So this would be.
Slider.
So if I go like this, oh, I guess I can't run it from here.
No, if you go up there, next to the edit mode, there is this arrow in a circle.
Yep.
If you click on that, you can run it.
I'm navigating around the bar again.
Yeah.
There we go.
Yeah, this one. And now you can move this slider and run it. You got to run it again to see the impact.
It's set in equilibrium, so it's not going to show. So the question is, when building for an article, I can obviously build this for my own experiments.
Yes.
But is there value in building anything more, or should I really just focus, for an academic article at least to start, on a solid exploratory model, solid data set, solid analysis of contingencies in space, and limit that? Because as you know, I have a tendency to go.
Yes, I would say the former limit that.
Okay.
You can, I mean, if the journal allows that, you can say that a learning environment is available.
I'm hoping that future classes of maybe games of complexity might have some conflict games in. But that's down the road. So the next question is, in the article itself, should I seek to, with a simplified structure, go through, present that dynamic hypothesis, and then go through module by module and show the structure?
Yes.
Through okay. So that's going to be an SD 551 exercise. The same format. I call that the Kareem format.
I'll redo your work. I don't mind. I like to learn, like redoing other people's work.
So you have two people who are willing to work.
Big question is policy space. What would you recommend to go through and sort of automate the testing of policy space? In Benson, I would do this with sensitivity analysis.
You can do sensitivity analysis here.
Okay, so let's walk through that real quick. So I got to get out of this first.
Is there a tutorial?
There's
tutorials. There's
documentation
online.
I don't like the video actually. I like to read and see pictures.
No, there's a lot of documentation.
Okay, great.
And there are videos also.
So I got to remember, how do I get back to the model?
You can do a policy run here. Now, for example, if you double click on the graph,
I can do a sensitivity analysis.
does it say sensitivity analysis anywhere? Or you can go to the model mode, which is click on this X squared and go to model on top model.
Run sensitivity.
On top it says tools, then it says model.
Where here?
There's only model. File, edit, model, window, help.
Yeah, if you go to model, yeah.
Okay.
Now you have run sensitivity.
It's not highlighted.
Wonder what, or run specs, I probably got to set up. Round those up.
Where's my highlighter?
You want to go closer?
No,
Yeah, I can increase it again.
Edit me is on.
Oh,
Do you wear?
I have to wear my glasses to be able to see, but going closer will not help very much because I'm basically seeing it with one eye. My one eye reads distance very well, the other does not.
So both of us, edit mode is on. Maybe that
Has to do with reading too late at night. And
yeah, there's no run sensitivity or run optimization.
does that have to do with the version
Run
you run?
sensitivity
I hope not.
should work. I don't know why it's.
I don't know if it has. When was it released?
It works on mine.
Okay, and yours was about a year ago? You got it, the license?
Yeah, I've been updating it.
Yeah, my updates stopped because my license ran out at 1.5, I think. I'll have to check my site. See, would know when sensitivity come in because it lives and dies by it.
I see. So
I'll check on that. That would make it much easier to be able to do.
we can process a renewal for you.
Okay, so let's do. But anyway, so you would go there and set up this.
How do I get this? Oh, sorry.
Is the sensitivity analysis inherently different than Vensim and its concepts? Or just you gotta press the button?
It's the same
Okay.
concept. You press the button and test it.
Let me check then on the licensing. We're running out of time. So doing the policy space analysis, it sounds like we can explore the spaces really well with the sensitivity. We can basically map a whole range of contingencies and then see it. You know, about how many system state maps should I try and present in one article, right? I've got
Yeah,
four
you can
quadrants.
choose there.
Yeah.
I did some sensitivity analysis on this cancer model.
Mm-hmm.
I can share that.
Yeah, I'd be interested because I'm trying to mentally think of between a 20 and 30 page model or article. I've got the background, the lit review, the hypothesis, the structure, and then probably room for three components or maybe four: a sensitivity, a state space, you know, some of those. But I got to be careful how many like components I'm putting in.
You
Or
could
work.
probably create a table for your sensitivity results,
Okay.
and then identify in that table what are the sensitive parameters, and then do your policy experiments based on those sensitive parameters, and possibly also building some additional information links.
2 years ago, I would wait until everything was done and then start shopping it to journals. Do you think I should take an abstract and start shopping it now? Or wait until the experiment results are done?
Yeah, I usually do it after the paper
Okay,
is
so
done,
after the
but
paper.
I mean, I don't, you can try it. I don't have any experience of doing such a shopping before, and I just do the complete article.
Professor Conrad said her PhD advisor, was somebody in Purdue, would just send the paper as is and use the editors and reviewers as people to revise and help them, because you're sending it to experts in that area, and they'll help you make it a better.
They might reject it, but they give you reviews.
Okay.
And I actually like that idea too, but I have trouble letting go. Like I want to send something that's really good to them, but it's another strategy.
Yeah, I'd rather be shopping earlier, because if they say this is great, this is good, I stop and I clean up at that point. You know, if I've accomplished my main goals, what I don't want to do with this is turn it into another 450-page supplementary. I want this very discreet and crisp compared to the emerging state actor model, which is great. I mean, I'm glad I did that. It'll make a great textbook one, but I don't want to do it again. So I'm sort of being a little bit more pragmatic about how to approach this.
Another question, side note, are you going to apply for that position at opening?
If it comes open, they're currently none open. They said that I'm considering it heavily.
Because I think that group is very good too.
Yeah. So there's a lot of considerations to do in that decision, but the first is it has to come up, and I have submitted a CV though to Elliot and Louise, just so that happens. All right, well that's I mean, we're at the top of the hour. We got a few minutes left, but I think that was a very productive meeting. Unless someone's on chat. Hold on, who's on chat?
don't know, I exited.
Nope, no, it's not Jeff. Okay, so we're going to stop the recording. And thanks, everyone.